Hello students, I am Sauradip Seth, lecturer in electrical engineering in Rajganj Government Polytechnic, Jalpaiguri. Today I am going to discuss about the working principle of three-phase alternator. For voltage generation, there needs to be a relative motion between field flux and armature winding. Then according to Faraday's law of electromagnetic induction, an EMF is induced in the armature conductor, which says that there must be a change in flux linkage for an conductor if there is to be a induced EMF in the conductor. For producing the relative motion between field flux and armature winding, there are two options. One option is field is stationary and armature winding is rotating, and the second option is field is rotating and armature is stationary. In DC generators, we use the option of field is stationary and armature winding is rotating, but in a DC generator we use commutators connected to the armature conductor. This commutator help us to produce the unidirectional voltage, but in alternator or synchronous generator there are no such kind of commutators used, so in the output we are getting alternating voltage. But in case of an alternator or synchronous generator, we generally use the second option, that is the field is rotating and armature is stationary. Now field poles can be generated either by using permanent magnet or by using electromagnet. Electromagnet is a current carrying through a coil which produces a magnetic field with north and south poles. As the rotor of the alternator or synchronous generator rotates in synchronous speed, so it is also called a synchronous generator. We all know that synchronous speed depends upon frequency and number of poles of the alternator, and frequency and number of poles of the alternator is always constant, so synchronous speed is always constant. We can also say that alternator rotates in constant speed. Now rotating magnetic field in alternator are obtained by rotating the field poles by prime mover. A prime mover can be a hydro or steam turbine, and these field poles are obtained by exciting field winding with the help of DC supply, which resembles a electromagnet. Now synchronous machines are doubly excited machines because we provide two inputs to this alternator or synchronous generator in its rotor. One input in the rotor is the mechanical input, and the another input is the DC excitation to the field winding present in the rotor. Here in the figure or the diagram in the right hand side, we can see that the excitation system is provided to the field winding and it produces the poles, and after that we rotate the poles with the help of a prime mover. DC excitation system provides DC supply to field winding and it produces static magnetic field. The field winding producing static magnetic field is rotated by the prime mover and results in production of rotating sinusoidal flux density distribution in the air gap space present between the rotor and the stator. This rotating sinusoidal flux density distribution or the magnetic field, when cuts or links the three-phase armature winding which is displaced by 120 degree in space, results in a three-phase induced EMF in the armature winding, and when the armature winding is connected to electrical load, current flows in the armature winding. Here in the diagram we can see a star connected three-phase armature winding in which each phase coil is displaced by 120 electrical degree in space. As these three-phase coils are displaced by 120 electrical degree in the space, because of this reason we are getting a three-phase voltage which is displaced in time. Here in this page, in the bottommost diagram, we can see the shape of a sinusoidally generated three-phase voltage which is displaced in time, and this sinusoidal shape of the voltage is obtained because we are generating sinusoidal flux density distribution in the space, or you can also say that we are producing a rotating magnetic field in the air gap space, and as the magnetic field is rotating, so the magnetic field when links the armature winding, it also creates a change in the armature winding because of this rotation. Now in the topmost figure we can see that how we provide the DC excitation to the field winding of a cylindrical rotor, and it produces a constant or static magnetic field. The direction of the DC current in the field winding can be seen by dots in the left hand side of the field poles, and in the right hand side of the field poles the current direction is represented by cross. Then for this very current direction in the field winding, if we apply the right hand thumb rule, then we can easily obtain the field direction for this given field current. Now there are something very important to note, that how this sinusoidal shape of the flux density distribution is produced. The sinusoidal flux or the sinusoidal shape of rotating flux is produced by proper pole profiling or pole shaping in salient pole alternator, and by varying the number of turns of the field winding in each slot in cylindrical rotor, with higher number of turns in slot in interpolar region, and number of turns in slot goes on decreasing while we move from the interpolar region towards the field poles. The flux is represented by the number of ampere turns divided by reluctance, or you can say the MMF divided by reluctance. So for producing the sinusoidal flux, either we can vary the number of ampere turns and keep reluctance constant, or we can also vary reluctance and keep the number of ampere turns constant. In salient pole rotor, we vary the reluctance by varying the air gap between the rotor pole and the stator. At the center of the pole face of the rotor, the air gap is minimum, and the air gap goes on increasing as we move from the center of the pole towards the edges of the pole, and so the reluctance value also goes on increasing from the center of the pole towards the edge of the pole, and the number of ampere turns in salient pole rotor is kept constant. And so in this way the reluctance is varied in such a way so that the flux generated resembles the shape of a sine wave. And in case of cylindrical rotor alternator, the number of ampere turns are varied and reluctance is kept constant, because the air gap is constant in case of a cylindrical rotor, and the number of ampere turns is varied in such a way so that the flux generated resembles the shape of a sine wave. Now static magnetic field cannot produce induced EMF in armature winding, because EMF is induced in a coil when there is a change in flux linkage with the coil. This change in flux linkage is produced by relative motion between field flux and coil. This is dynamically induced EMF. So for this very reason, it is very important for us to produce a rotating magnetic field, and this rotating magnetic field is produced by rotating the field winding of the alternator. This rotating magnetic field helps in creating a change of flux linkage. So that's all in this presentation. Thank you.